We can all read the thoughts, the feelings of others. Just by interpreting the shapes and movements of the muscles of a face, we can understand a little of what someone is thinking or feeling. So just how good are we? And is everyone equally able to see beyond the smile?
I'm inclined to think happy. Yes, happy. Without question.
I think she's got a secret.
I think it's a very interesting look. She looks as though she's sort of contemplating.
She's so famous that it's hard to have an original thought about her. Serenity, happiness.
We seem to be born to be naturally able to interpret people's expressions. But there are some people who have extraordinary difficulty in this area. Some people have difficulty because of brain damage acquired during life. Others seem to be born with specific kinds of brain damage, which makes it very difficult for them to interpret even a simple face. We look at this face here. If I asked you the question, here's Charlie, which one of these 4 sweets does Charlie want? The normal child and adult finds it incredibly easy to use the information in the eyes to infer a person's desire. Children with autism, for example, developmental disorder, have very great difficulty in identifying a person's desire on the basis of their gaze direction.
Investigations into the role of facial expressions in human communication have a long history, attracting even Darwin's interest.
The movements of expression give vividness and energy to our spoken words. They reveal the thoughts and intentions of others more truly than do words which may be falsified.
Well, Darwin and his followers, even in this century, have suggested that universally there's only a small set of so-called basic emotions which are recognised across different cultures. What we were interested to find out was whether people in different cultures could actually recognise a far wider set of mental states from the face. Not just the basic ones like happy, sad and afraid, but complex ones like revenge, pity and shame. Hi Ian.
Hi Simon.
I've brought some pictures along.
Okay.
By David Hockney.
Right.
And the idea is we're going to show these to subjects and ask the subjects to choose between a pair of words.
Right.
Which word best describes what the person is thinking or feeling. So this one here, for example, the choice would be revenge or forgive.
Okay. So
and they just got to decide as quick as they can.
Right, that's the whole face, isn't it?
It's the whole face, yeah.
They'll reproduce without any problem at all.
Great. Okay, leave it with you. Thanks again.
Okay.
Cheers.
The process of looking at faces and working out what people are feeling seems straightforward. But would Simon Baron-Cohen's subjects all see the same emotions lying behind these faces? He looked at the reactions of 20 Spanish, Japanese and British-born subjects to see if they would respond in the same way to the same pictures. Here's just one of the pictures they looked at. For this Hockney, the choice was between an interpretation of revenge or forgiveness. Most subjects thought the picture showed revenge. However, some, a quarter, thought that the picture showed forgiveness. What about the hypothesis that the nationalities have the same interpretations? The Spanish and Japanese do have identical results. However, the British are different. 3 more in this sample thought the picture showed revenge. Is this a meaningful difference? Perhaps it's a chance occurrence in the samples, or perhaps it represents a genuine difference between the underlying populations. This is a contingency table, and a suitable test to apply to contingency tables is the chi-squared test. On the right, there's the total of those that made the revenge and the forgive choices, a ratio of 3 to 1. And on the bottom, there's the total subjects in each group. So what does this tell us? Well, what if there really wasn't a difference in the underlying populations? And what if we found an ideal sample which perfectly represented those populations? Then, what would the data look like? With a 3-to-1 ratio in each nationality group, the bars would have looked like this. These are called the fit values. However, the actual sample data wasn't exactly the same. The differences, the sample data minus the fit value, are either positive or negative and are known as the residuals. Let's look back at the table. The residuals are all squared. We're not interested in their sign, simply their size. To take into account the fit values, we divide by 15 for the revenge and 5 for the forgive subjects. For chi-squared, we simply add these together to give 24/15 or 1.6. Now, if there was no difference between the populations and we ran the experiment many times, we'd get lots of new chi-squared values. Some similar to 1.6, but others would be less and others more. This is the sampling distribution. It's very unlikely we'd get a value out here if there was no difference between the populations. Very few samples lie here. In fact, only 5% lie beyond this critical value. And Simon's actual value lies here, amongst some of the most common findings. We can't say for sure there's no difference between the groups, but Simon takes this as a confirmation.
What we found was that the statistical analysis told us that when you looked at all of the faces combined, as it were, looked at the scores across all the different items in the test, there was considerable agreement across the different cultures. And indeed, since the test had included complex mental states, this was telling us that the agreement, the universal recognition of emotions in the face, was far wider than Darwin had assumed.
So there seemed to be a similarity, at least amongst these three cultural groups, in their interpretation of emotions just from facial expressions. But what aspects of the face are providing the vital clues?
Facial expressions are far more important than eyes. Eyes can lie, you say, can't they?
I feel myself that the eyes, a person's eyes, tell you the most about a person.
Yeah, I think she's sad, actually. Look at her eyes. I think she's got sad eyes.
Expression in itself, or the language of the emotions as it has sometimes been called, is certainly of importance for the welfare of mankind. To understand as far as possible the source or origin of various expressions which may be seen on faces around us ought to possess much of interest.
What do you think of yourself now, then?
What we didn't know from Darwin's theory was which part of the face might be critical in making these judgments. What we found from other studies is that it's the eye region of the face which contains critical information for judging a complex mental state. You can use the mouth and the eyes, or the whole face, for basic emotions. When it comes to complex emotions, the eyes seem to be sufficient for you to make that judgment. This might be of interest not only for identifying why children with autism can't pass these tests. Maybe they don't understand the eyes in the same way. But it may also be interesting to find out whether there are differences within the normal population in how good we are at judging a person's mental states just from their eyes.
So the eyes provide the key to effective interpretation. Now the question was to see if everybody within one group, Cambridge undergraduates, would perform the task equally well.
This study was similar to the multicultural study in design, but this time all we had was the eyes, taken from photographs of faces from fashion magazines. And this time we were testing not different cultures, but the different sexes. How would men and women perform on this sort of a test?
Reflective or unreflective? Most people thought reflective. The contingency table looks like this. For women, 22 out of 25. For men, only 16 out of 25. And the value of chi-squared is 3.95. Now this chi-squared value falls just beyond the 5% critical value, meaning the null hypothesis can be rejected at this level. Perhaps this is enough to reject the general idea that males and females interpret the eyes in the same way. From this we know there's a difference, but how big is it? 88% of women and 64% of men said reflective. That's a 24% difference. We can show this as part of a range of possible differences. Women doing only a little better than men will be shown here, and women doing much better than men here. The Cambridge experiment produced a difference of 24% with just a small sample. What about the population as a whole? Well, it's not possible to be so accurate, as there's a range of plausible values. This is called the 95% confidence interval. All we can say is that according to this experiment, with this sample size, the real difference between men and women in the population is likely to lie somewhere in this range, not so precise. With a bigger sample, it would be possible to narrow the range and tie the size of the difference in the population as a whole down to a much more accurate value.
What we found was, as predicted, there was a sex difference in the direction that we expected. Women were indeed better than men, in subtle but statistically significant ways. If you looked at any one face, there was no sex difference, but if you added each score across the different pictures and compared the groups, then there was a sex difference.
If this sex difference was true of the general population, then Simon Baron-Cohen believes this might say something very important about the links between the male brain in general and the brain of children with autism.
Well, now we have two pieces of the jigsaw. On the one hand, we know that children with autism have a lot of difficulty in interpreting mental states from the eyes, in mind reading. On the other hand, we also know that men in the general population seem to be worse than women at this same ability, mind reading. We can make sense of these two pieces of information by noting that autism is also a largely male condition. Something like 3/4 or more of children with autism are male. And it may be that there's a link between these two facts in terms of how the male brain develops.
But Simon knew there'd be problems in making statements about sex differences in the population as a whole. So far, he'd based his conclusions on small samples of Cambridge undergraduates in laboratory conditions. In the streets around Cambridge, one of Simon's colleagues, Jessica Hammer, replicated the study in an attempt to see if what was true of the undergraduates was also true of the wider population of the city.
Good. Is this person experiencing attraction or repulsion? Attraction. If we only work in the lab, the main problem with the experiment is that you're working with a limited population. In this case, it would be undergraduates at Cambridge. It doesn't say anything about older people, younger people, people who are out in the real world and working. So what we're trying to do now is come out into the street and get a slice of real life, get a random sample that includes people from all walks of life and all ages. But the other problem is that people who stop to talk to you in the street are a self-selecting group. Not everybody is in the street during the day, which is when I've been testing. For example, I'm excluding anybody who's working full-time during the day. Also, it limits itself to people who are willing to stop and talk to a complete stranger. These people could be more extroverted and more social than other people and thus be better at reading eyes. So our results are probably not completely accurate, but it's certainly much better than the limited population that we had in the lab.
The Cambridge studies are obviously limited to people who we've tested here in Cambridge. That's to say, they may not be representative of the wider population. We've got a lot of students here, we have a lot of visitors here. We don't know whether results obtained on small samples in one place can generalise to other places.
Hello, tonight on Tomorrow's World, the biggest series of mass experiments ever. Right here, right now, live on Megalab 95.
National Science Week offered Simon Baron-Cohen the opportunity to test his ideas on a much larger sample.
I think the grand vision of Megalab was to try to promote science in the eyes of the public. And we thought, what better than actually to involve the public in an experiment? And I think between the BBC and the Telegraph, we had a potential of 18 million people at our disposal. And then, hopefully, with the involvement of all these maybe hundreds of thousands of people, we thought we can come up with a fun new discovery for science.
The Telegraph published a picture of a set of eyes and asked men and women amongst its readership whether they were friendly or hostile. On live TV, the same set of eyes were now shown to millions of people. With both the Telegraph and Tomorrow's World, they hoped to confirm that there was a sex difference. But now, with such a large sample, they expected to get a really accurate sense of its size.
We were very anxious to make sure that the experiment worked, or at least to be sure that there was a good chance of it working, and to give an interesting result, a split difference between men and women. So what we did was, in the weeks running up to the show, we first of all trialled the experiment around the office, and then we did a bigger trial on the queue waiting for a Lenny Henry show. And we got them to file into a little room and did the test with them there. And both tests showed that men clearly saw aggression much more than women did in this expression. About 30% difference there was.
So let's see what the people in Glasgow made of it. Are these eyes hostile or friendly?
Now, it's very interesting. The women here seem pretty evenly divided, but just look at those men, all crowded around the hostile area. Must say something, I think. Well, what we want to know is, what about the rest of the nation?
I think we wanted to make sure the experiment would deliver a result, so there was a pilot study that suggested that there would, for instance, be a gender difference, and that's what we'd all come to expect. And in fact, when I had to write the story for the first edition of the Telegraph results supported the gender difference, so everything was going to plan.
How many people called him?
34,000.
34,000. Brilliant response. OK, that's good. Now let's find the answer to the emotion experiment. Was the face hostile or friendly?
You didn't really think I'd forget, did you? I know I may not be the best grandson in the world. I'll never forget your birthday. Happy birthday, Gran. From me, Janice, and the boys.
Oh, you're such a good boy. Such a friendly boy.
The climax of the programme depended on the result of this experiment. With 3 minutes to go before the result was due to be announced, we had the first indications of the result, what it really would be. And it was completely different from anything that we'd expected.
What about the men? Did they fare any better? The percentage is 36. The men just pip it.
I had to rush out, rewrite the story from top to bottom. And in fact, if you look at the headlines, you find that this is the first edition headline, where, yes, we've got the gender difference, everything's fine. And then, as the night wore on, this edition headline appeared, just reflecting the different interpretation of the experiment.
Those are the results, but what's the meaning behind them?
Simon, is this big news?
This is a very interesting result, because you can see here that I was put on the spot somewhat. I was asked to explain this rather unexpected result. The production team had expected and indeed hoped for a massive sex difference, even on the basis of a single item.
But was this result really a problem? Is it inconsistent with the Cambridge study? The original result from Cambridge showed a 24% difference. But remember, that was just one of a range of plausible values. In Cambridge, women did better than men. On the night of Megalab, men did better than women. So the result is beyond zero in the negative domain, with a 3% difference between the sexes. Now, if the confidence interval for this Megalab result was wide enough, it could have been consistent with the lab-based result, because they would have overlapped. But with over 30,000 subjects, Megalab's confidence interval narrows to this range. Megalab does seem to contradict the Cambridge result.
Right now, we have 6,000 automatic phone lines waiting to take your calls.
But what was the cause of the sudden switch in results? Does Megalab necessarily invalidate the Cambridge study? One problem is that while the telephones offered an increase in sample size, they also introduced a major loss of control over the experimental conditions. Sample sizes aren't everything.
I think it is undoubtedly true. If you have a large sample, everything else being equal, you'll get results you can be more confident of. However, with something like Megalab, it's such an unusual situation, people taking part from their living rooms, you can't do proper controlled experiments. So it's a compromise. You have, on the one hand, people taking part in experiments, getting enthusiastic about science, but on the other hand, experiments that perhaps aren't controlled in the exact ways that you'd like them to be.
One approach, you're going to drag a select number of people into the laboratory, and there you're really dealing with very small numbers of people, tens, maybe 100 if you're lucky. They're often students who've been kind of dragooned into doing the experiment. Whereas if you want to look out in the real world and use the UK as a laboratory, then you can go up into hundreds or maybe thousands, but then the problem is actually defining who you're looking at. Then you've got to worry about their age, their sex, their socioeconomic class, their background, where they live. There's millions of factors that get into the experiment that make it more difficult.
But it wasn't just a problem with lack of control in Megalab. In the Cambridge labs, the sex differences didn't show clearly on every photograph. They only appeared after analysis of a wide range of photographs. In some sense, Megalab was no longer the same experiment.
And I suppose we should have known, and in retrospect we can say, that if there is a sex difference in this area, it only shows up in subtle ways when you take a composite measure across a lot of different items in a test battery. So simply having the large sample size doesn't necessarily get at the subtle difference going on.
But I guess that's what science is all about. You're testing your theories against the real world. We thought we got it sorted out. In fact, our theory wasn't backed up by the Tomorrow's World experiment. We had to change our interpretation.
Yep, it's official. There was a night when we discovered you weren't very good at finding the right emotion.
You've got your model, you're testing it against reality, and it didn't quite work out the way we expected. That's science.